evening. Today we are going to start with the topic matter. So before starting with this, we must know what is matter actually. So anything which has a mass and occupies space is called a matter. So let's say like I have a marker in my hand, right? It is having some mass and also it is occupying some space like from my one finger to the other end of the finger. So basically it is a matter because it's following the two conditions, that is it is having a mass and it is occupying some space, right? Now further, if I move on to the classification of matter, you have already read the states of matter. Like these things we are studying from previous classes. So if I talk about states of matter, we are having, in total we are having 5 states of matter. But which we are going to study here, that is only about the 3 which are very common: solid, liquid and gas. In solid, you know that particles are very much closely packed. They don't have spaces between them. There are no intermolecular spaces inside the solid. So particles are arranged something like this. Like you can see, these are very much tightly packed, right? Whereas if I talk in a liquid, in liquid particles are loosely packed as compared to solid. But if I talk about gas, in gases particles are very much loosely packed. So in comparison to solid, liquid and gas, the state of matter which is having the largest intermolecular spaces in between them, that is gases. Okay, and after that it is liquid and then it is solid, which is having a negligible space in between them. Next, if I talk about their shape and volume, so you can see very well like any of the solid object. Like again, if I talk about this marker, it's a solid. It's having a fixed shape. Its shape will be this only. And moreover, volume is also fixed. So basically in solid, what you see, it is fixed shape and fixed volume. Whereas in liquid, you can see, like if you pour water in a glass, right, it will occupy the shape of glass. If you pour the same volume of water in some bowl, it will occupy the shape of that bowl, right? If you occupy the same amount of water in some other container, right, it will occupy the shape of that particular container. So which means that liquids have no fixed shape, no definite shape, but they do have the definite volume. Because in pouring the water from one container to the other, volume doesn't change. Volume remains fixed. So that means liquids have fixed volume but no fixed shape. So this doesn't have any of the fixed shape, right? If I talk about gases, gases neither have fixed shape, nor they have fixed volume, right? So this was about the classification of matter in terms of solid, liquid and gas. Like if I talk about gas, like you can see when you light an agarbatti in your room or somewhere in your mandir and everywhere, right? Okay, so in that case, when you light it, the particles get diffused. That is why you can smell the fragrance. You can smell that everywhere in your house, right? Because its particles scatter everywhere, and that which you find out the smoke or fog coming out of that, you can see it doesn't have any particular shape. It's having an irregular shape, it's not definite shape, and also there's a no definite volume, right? Like you can see in our cylinders, in our LPGs, our gases are compressed, right? Because their volume can be you can say compressed. They don't have definite shape, they don't have any of the definite volume, right? And from this one, another point comes to our mind that gases can be compressed very much easily. Liquids can be compressed but to the lesser extent as compared to gases, and solids can't be compressed at all. Can I compress this marker? If I press it, if I put all of the force, it still can't be compressed, right? So this was another property of solid, liquid and gases, right? So next, further moving on to the classification of matter at macroscopic level. Macroscopic level means if I see from the outer point of view. One is macro and one is micro. Micro means when we go internally, when we see all the internal part of the matter, and macro when we see just the outer parts, right? So from the basis of macroscopic level, we can classify the matter into two, that is pure substance and mixture. Okay. So pure substance means which is having a single type of substance, which is very much pure, right? The type of atoms, the type of substance is single in that. Like if we talk about that gold, this gold is very much pure, right? So we are talking about the single kind of substance over there. That is what we say as a pure substance. In pure substance, we further have the sub-classification, which are element and compound. Elements are those which are having only one type of the atom. Basically, if I talk about gold, Au, silver, right, hydrogen, helium, these all are single elements. Single type of atoms are present in between them. If I talk about gold, so gold has only gold atoms, not any other element atoms in that, right? But if I talk about compound, it is composed of more than two types of atoms, right? Or you can say two types of atoms. Like if I say water. So what is this water? So water is composed of two elements. One is hydrogen and other one is oxygen. Now these elements are combined in a fixed ratio by mass. This is the thing you must know. In compound, elements are combined by fixed ratio by mass. So you find water from anywhere. You can have the RO water, you can have the sea water, any water from wherever, whatever the sources of the water. It will be always having two elements of hydrogen and one of the oxygen. And the ratio will be always 1:8. It can't be changed. It's a fixed ratio. Okay. Similarly, if I go on to the other classification, that is mixture. Now, mixtures are also similar to the compound, but there's only one difference. Mixture is also composed of more than one elements. You get more than one thing. Like in normal senses also, if we mix two or more, three things together, we say it is a mixture, right? But in mixture, there's a no fixed ratio. You can combine them in any of the ratio that will be known as a mixture. Like if I say salt and water, I'll combine those salt and water. That salt and water can be any of the ratio. It's not necessary in what ratio I am combining the salt and water. You will be also combining the same. So that ratio isn't fixed. So when your ratio isn't fixed, but the elements or but the substances are mixed together, that is known as a mixture. So in mixture, you will remember that there is no fixed ratio, right? So just have a screenshot of this and then I'll go further to the mixture classification. So now let's move on to the mixture classification. So in mixture classification, we have further again two sub-classification, that is homogeneous mixture and heterogeneous mixture. So word homo means same. That means you have throughout the composition, same composition, right? Like things get mixed very uniformly. You can't see the substances which you mix together. After mixing, you can't see those substances differently. That is basically homogeneous mixture. So just see over here, mixture is classified into two, that is homogeneous mixture and heterogeneous mixture. So homo means same, that means uniform composition, and heterogeneous means non-uniform composition. So basically, when homogeneous mixture we talk about the uniform composition. Like if I add salt and water, it is uniformly mixed. Now basically you can't see the salt and water differently. You'll see the salt mixed in the water, right? But if I mix oil and water, those will not get mixed very uniformly. You will see a different layer of oil and water in that basically beaker in which you are mixing those, right? So in which the composition is not uniform, basically which can be separated. That is your heterogeneous mixture, right? So some of the mixtures can be separated and some not, right? So basically you need to know this, that homogeneous have the uniform composition and heterogeneous do not have the uniform composition, right? Now when I was talking about the states of matter, you must know the interconvertible states of matter, that how states of matter can be converted from one form to the other form. So let's say if I talk about solid and I ask you to convert the solid into liquid. So you very well know, if I take an example of ice. Ice is a form of solid. When I convert it into liquid, what will I have to do? I will just put my ice out of the freezer and it will melt and it will convert into the liquid. As simple as that. So basically what you came to know, that solid can be converted into liquid just by the help of melting. Okay. These are interconvertible. Liquid can also further be converted back into the solid. As you know, water can be converted back into the ice. How? If I put back water into the freezer and it will convert it into the ice. So basically liquid goes back to the solid with the help of process called freezing, right? But if I want to go from liquid to gas, basically liquid, water. Think in terms of water. If I want to vaporize the water, I want to form the vapors of water. So what will I do? I'll just do the process of vaporization. And then if I want to go back gas to the liquid, I'll just condense those vapors and it will be converted into the liquid. Now the thing is, if I want to convert solid directly into the gas, what is that process called? That is just called as the sublimation. Sublimation. And when I want to come back from gas to the solid, that is known as deposition, or you can also call it as a desublimation. So basically the things which is like solid converted to liquid and liquid converted to gas, right? These are very much understood, like if we talk in terms of ice. But if I am talking about solid directly into gas, that means in between state of matter which is liquid, it is not occurring in that case. So what is example of such a process? As you know, that when we store our clothes, like summer clothes in our almiras or whatever, wherever we store it, you have seen that parents some of the time they put naphthalene balls in that. There are small medicines which are put in that. Basically these are naphthalene balls. So naphthalene is having the property of sublimation, right? When you take out the clothes after some time, when you need to wear it, so what you can see that those naphthalene balls are not present over there. Basically what happened, at some particular temperature, when they get that particular temperature, they get sublimed. They sublime, they form the vapors and they wash away. So basically when you convert solid to gas, directly into gas, that process is known as sublimation, and you can remember the example of naphthalene balls. And when I say gas comes back to the solid, again without having the state of liquid, that is known as desublimation or deposition, right? Again in that case you can remember the example of frost. As you have seen in very with the areas where the temperature is very much low, in negatives it is. So you can see that on the window panes you can have the solid layer of the ice, right? So basically that is known as a frost. In that process, in that case, desublimation is used over there. Okay, so this was the general classification of states of matter. And now we are done with this topic, classification of matter. Thank you. So now next we have the properties of matter. Like we have talked about the matter, its classification. Now we are gonna start about the properties of matter. So we are having the physical properties and chemical properties. So basically physical properties, these can be observed, or you can say these can be measured without changing their identity, right? Like if I say about shape, right, about order, about their malleability, ductility, these all the things are considered in the physical properties, okay? But if I talk about the chemical properties, in chemical properties you need, if you want to measure, if you want to observe the changes, for that you need to change the identity of the substance, right? These can't be measured without changing their chemical identity. So in further physical we can see that you have qualitative and quantitative, right? This is a further sub-classification. Qualitative is difficult to measure because you don't have a proper unit, or you can say proper number in which you can measure it. Like if I say malleability, something which can be drawn into the sheets, which can be beaten into the sheets. So how can I define that this substance is more malleable and this is less malleable? Right? This is just on the observation, but we can't change the identity of the substance and then measure over that, right? Now, if I say about ductility, what is ductility? Something which can be drawn into the wires. Lustrous, how much shiny is the some substance? But I don't have that particular number or particular value, particular unit by which I can say that this substance is more shiner than this. But I knew that if I talk about a gold and to the next it is something like if I talk about marker. At one side I have a marker, on the other side I have a gold ring. And from that, what I can say that gold ring is more lustrous. It is more shiny than the marker. That is just from my observation. But there is no definite unit or no definite value in which I can compare that. Okay. Next is quantitative. Quantitative which are having some units like length, volume, breadth, height. These are the some units. Like if I say this marker length is 2 meter and there is another marker whose length is 3 meter. So here is the comparison on the basis of value, on the basis of units on which I can compare these two lengths. Okay. Similarly, breadth, height, area, volume, this all have the particular units. You very well know about that. Now we are having total 7 base units. Okay. 7 to 8 base units we have. In that case, these are the 7 base units I have written over here. Length. Its unit is meter. Before that, I want to tell you that we have SI system of units, like which is accepted internationally. Okay. Like it's not like here we are using meter and in another country will be using something else. So there is a particular system of units which is made to accept internationally. Right? So that there's no any chaos created. Like in this area, someone is doing research, he or she is having some other value of units, and in another area who is doing research, he or she is having some other value of units. So that will create very mismatch and very chaos over there. So we can't match our results with the other ones, right? So this is why we have made a internationally accepted system of units which is known as the SI units. So for that we have length, meter, mass, kilogram, time, second, electric current in amperes, temperature in Kelvin, amount of substance in mole, which we'll study in further classes also about this. Luminous intensity is candela. Okay. So these are total 7 basic units. 1, 2, 3, 4, 5, 6 and 7. These are the 7 base units which will be studied. There are also other units, but those units are derived from only these base units only. Okay. Like if I talk about volume, right? You know volume, in case of volume our formula is length into breadth into height. If I talk about cuboid in general, okay. So length unit you very well know. We have talked about SI unit, meter, height also meter. So unit comes out to be meter cube. Right? So basically this is the derived unit. We have derived the unit of volume from the base units. Okay. And in similar way area unit is meter square. So these units are derived from the SI system of units which are the base units. Okay. So moving on to the further, next it is mass. What is mass? Mass is amount of matter contained in a body. How much matter is contained in a particular body, that is mass. You very well know, you must know even that what is the difference between mass and weight. Mass is always constant. Whether you are on Earth, whether you go to the moon, whether you go to some other planet, mass will not be changed. Whereas weight changes. You also know that when we go to the moon, there's a difference in weight as compared to when we are on the Earth, right? So always remember that mass is constant quantity. Okay. Next, moving on to the quantity, that is temperature. So in temperature, we have 3 scales. One is Celsius, another one is Fahrenheit, and third one is Kelvin. Okay. So if I talk about the freezing point, boiling point, and human body temperature in all of the 3 scales, you can see that values are different. Okay. Like in degree Celsius, freezing point is 0 degree Celsius. In Fahrenheit, it is 32 degree Fahrenheit. In Kelvin, it is 273 Kelvin, right? So values are different. It varies in the different scales. But how can we convert the one value into the other value? Like if I know the value of Celsius, degree Celsius, but I need to convert it into the Fahrenheit. So for that, I have some interconversion. I have some formulas. So those are, if I have degree Fahrenheit, how can we change into the Celsius? 9/5 into the value of Celsius plus 32. If I have the Kelvin, how can I change into Celsius? Degree Celsius plus 273.15. So this is the conversion of Celsius to Kelvin or Kelvin to Celsius, and this is the conversion of Fahrenheit into Celsius or Celsius into Fahrenheit. And you need to remember one more thing, that Celsius values can be negative. It is possible, but in case of Kelvin, you will not have any of the negative values. Okay. So this was just about the system of units which you must know. At least these 7 base units you must know about that. Further units will be derived from this, that we'll study in the further classes also. Okay, thank you.